Welcome friends, hearty welcome to you. In this session, we will briefly touch upon what is rank of a matrix and what will be the values for a 3 by 3 matrix. What will be the values for rank for a 3 by 3 matrix. So, let's try to understand the definition of the rank of a matrix. The rank of a matrix is maximum of the orders of the non-singular square submatrices of a matrix. What's the meaning of that? So let's try to take some simple example. Let us say matrix A is equal to, so we have a matrix A with elements A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, now let's take this and see. Maximum of the orders of the non-singular square submatrices of a matrix. Now let's try to understand this step by step. Let's dissect this. Now where we have a problem is, first we don't know what is the meaning of submatrix. We know what is square, we know non-singular. Okay, let's try to understand what's the meaning of a submatrix. A submatrix is a matrix which is obtained by deleting some rows and columns from a matrix. Suppose you take this column, you know the rows R1, R2, R3, and the columns are C1, C2, similarly C3 columns you have, and here you have rows. Okay, now suppose I remove C1 and C2 columns. Okay, let us remove C1 and C2 columns from this matrix. What I will have? I will have another matrix. If I remove C1 and C2, I will have A13, A23, A33. This is called as a submatrix of A because you are removing some rows and some columns. Then the resultant matrix is called as submatrix. Let's look at another example. Suppose I have removed R1 and C1. I have removed R1 and C1. What happens now if I remove R1 and C1? First row is gone, first column is gone. So what is left out is A22, A23, A32, A33. This is also another submatrix. So you can have submatrices of a particular matrix. Now can you see what is the difference between here the first matrix and the second matrix here? The first one is having 3 rows and 1 column. That means it's a 3 by 1 matrix. Whereas if you look at the second one, you have 2 rows and 2 columns. It's a 2 by 2 matrix. So the second matrix is a square matrix, as you know. Now let's go back to the definition. Maximum of the orders of the non-singular square submatrices of a matrix. Now we know what's the meaning of submatrix. Submatrix means you simply remove a row or a column and make sure that you are getting a square submatrix. We are only interested in square submatrix. That means what I should do? I should remove both row and column. Then only I will get a square submatrix for 3 by 3 matrix. And we are only talking about 3 by 3 case. Okay, right. So if you want square matrix, what will be the next after 3 by 3? You can get only 2 by 2 because after 3 by 3 the next one is 2 by 2 and the next one is 1 by 1. 1 by 1 is nothing but an element. So how to get 2 by 2 submatrix? You take any row, any column, you just remove them. Any row, any column, you remove them. You will get square submatrix of order 2 by 2. Okay, right. Maximum of the orders. That means what can be the orders of this matrix? If let us say, let us try to see what will be the values of rank of a matrix if of a 3 by 3 order. Okay, rank of A 3 by 3 matrix it is. Okay, right. So what can be its values? It is equal to 3 if A is non-singular. What is the meaning of non-singular? Non-singular tells me that the determinant of the matrix is not equal to 0. So can I say det is not equal to 0. Okay, next, what else it can be? It can be 2. When it will become 2? Just now we have seen. When it will become 2? It will become 2 if A is singular, A is singular and if A is singular, and that means what's the meaning of that? A is singular means A determinant is 0. Determinant of 3 by 3 matrix is 0 and at least one 2 by 2 submatrix is non-singular. One 2 by 2 submatrix is non-singular. That means one 2 by 2 submatrix determinant is not equal to, then the rank is 2. When the rank will be 1? When both the cases fail. That means A is singular, A is singular. Not only that, all 2 by 2 submatrices, let me just go this side, all 2 by 2 submatrices are also singular. In that case, the rank of the matrix will be equal to 1. So, since we are interested in 3 by 3 only, if you take a 3 by 3 matrix, its rank is determined by, first if the matrix determinant is 0, then the rank is 3. Sorry, if it is not 0, then the rank is 3. If it is 0 and any 2 by 2 submatrix determinant is not equal to 0, then it is 2. If both the cases fail, that means A is 0 and also all the 2 by 2 submatrices are also equal to 0, then the rank of the matrix is called as, value of the rank of matrix is 1. So that's briefly about rank of a matrix. What we will do in the next session, we will try to solve some examples. Maybe we will do one example now itself. Okay, let's do one example now and try to understand whatever we have just now learned. Okay, just give me 1 minute. Okay, I am back. We have a matrix now. Let us take this matrix. Let us say B equal to 1, 2, 3, 2, 3, 4, 0, 1, 2. Let's try to find out the rank of this matrix. So how I have to check now? First I have to check whether det of B is 0. If det of B not equal to 0, that tells me rank of a matrix. How will specify rank of a matrix? We'll say rank of B equal to 3. Let us check that first. What is det of B? Okay, right. Just alienating so that we are clear. We'll use only this space. What is det of B? Let me take first column because there is one 0. I take this one. Okay, 1 into, this is plus, this is minus, this is plus. 1 into 3 into 2, 6 minus 4. Then I have minus 2 into, if I go for 2, I'll remove this row and this column. I'll have 2 into 2, 4, 4 minus 3, 1. That's nothing but equal to 2 minus 2 into 1. That's equal to 0. Oh, so the rank is not equal to 3. Right? Because we found the determinant is equal to 0, so the rank is not equal to 3. Now, can you take any one submatrix and prove that its rank is, its determinant is not equal to 0? Then immediately I can say rank equal to 2. So let's take one. Let us say first one itself, I have 1, 2, 2, 3. Okay, what is the determinant of this? Nothing but 1 into 3 minus 2 into 2. That's nothing but 3 minus 4 equal to minus 1, which is not equal to 0. Therefore, rank of the matrix is 2. Okay, we will do some more examples in the next videos. Why we are going through rank of the matrix? Because rank of the matrix plays key role in identifying the solution of system of linear equations related to consistency of the system of equations. Thanks for visiting. Bye for now. See you in the next video.